Good morning, good evening, or good afternoon, depending on where you're joining us from today. We would like to welcome you to today's session of the Azure webinar series. Our topic today is New Innovations with Azure Core Compute. Before we get started, I'd like to go over a little bit of housekeeping. We do have subject matter experts with us today who will be answering questions in real time, so please pop any questions that you might have into the Q&A window and we will get to them as quickly as we can. Also, on the top right-hand corner of your console, you will find a resources area. Any links mentioned in this session will be easily accessible for you there. Right below the resources widget, you will find a survey. Please provide any feedback that you have around today's session. Finally, this presentation is recorded and you'll receive a link to view this session on demand in your email within 48 hours. We have 3 speakers with us today from Microsoft. Mo, handing it over to you.
Hello, and welcome to the Azure webinar series, and this session on new innovations in Azure Core Compute. My name is Mo Farhat, and I'm happy to introduce you to a slate of new Azure VMs alongside my colleagues, Priya and Sasha. We'll start with an overview of Azure virtual machine types. I'll introduce you to Azure's new ARM-based VMs, and talk about how you can get preview access. And then I'll pass the baton to Priya to introduce the new EBS V5 VMs, and Sasha to talk about the new L-Series storage optimized VMs. We'll close with a round of Q&A, and you can enter questions in the chat window at any time during the session. Azure offers a broad and diverse range of virtual machine types designed to meet the needs of the applications you create and the workloads that drive your business. From A-Series machines that help you get started with development and test environments at a low price of entry, burstable VMs that give you performance when you need it cost effectively, and general purpose compute and memory optimized VMs that fit the needs of most enterprise workloads. The Azure Virtual Machines portfolio also includes storage optimized VMs, GPU accelerated VMs for AI, graphics intensive, and visualization workloads, as well as instances able to tackle the most demanding high performance computing scenarios. So we'll present the recent additions to the Azure Virtual Machines portfolio today's session, specifically the new VM series in the general purpose, memory optimized, and storage optimized VM families. We aim to provide customers a choice of processors and GPUs that best address your workload requirements, including a new choice of Ampere Ultra ARM-based VMs. We're proud to introduce Azure's new and first ARM-based general purpose VM types, the DPS and DPLS series. These VMs are designed for application, web, and game servers, small and medium-sized databases, microservices, EDA, and media encoding workloads. The DPS instances come with 4 GB of RAM per vCPU in sizes up to 64 vCPUs and up to 208 GB of RAM. The DPLS family comes in 2 GB of RAM per vCPU in sizes up to 64 vCPUs and 128 GB of RAM. Both the DPS and DPLS series support local SSD temporary storage options, as well as a range of remote storage options from standard solid state and hard disk drives and premium SSD storage, with support for UltraDisk remote storage coming soon. We're also excited to introduce the EPS series, the new memory optimized ARM-based VM type in Azure. The EPS series is designed for memory-intensive, medium and large databases, in-memory caches, and data processing workloads, and comes with 8 GB of RAM per vCPU in sizes up to 32 vCPUs and 208 GB of RAM. The EPS series also supports local SSD temporary storage sizes, as well as the range of remote storage options, also with UltraDisk support coming soon. Let's take a deeper look at the processor behind Azure's ARM-based VMs. The Ampere Ultra processor, designed for cloud-native workloads by Ampere Computing. The Ultra processor delivers high performance per vCPU with predictable performance characteristics that scale linearly with your workloads in Azure. Ultra is a 64-bit server processor based on the ARM Neoverse N1 architecture with single-threaded CPU cores that run at a frequency of up to 3 GHz. That's among the fastest Neoverse-based processors available. Each vCPU is a physical compute core with dedicated resources that provide performance and security isolation for your workloads. The Ampere Ultra cores are based on the ARM version 8.2 architecture and support 228 wide SIMD units with int8 and FP16 instructions that accelerate the execution of machine learning inference applications. Customers tell us they're using ARM VMs in a growing number of workloads, and there's broader support for ARM in the ecosystem now than there's ever been. Many workloads built on Java, .NET, Python, PHP, and interpreted languages run on ARM with minimal porting effort. Users of open source databases, such as Postgres or MySQL, in-memory caches, such as Redis and Memcached, can also deploy on ARM with little to no changes to their application code. Scale-out workloads will also benefit from the consistent performance and linear scaling of Azure ARM-based VMs. We're also excited to help Windows client developers build more efficiently with Windows 11 Pro and Enterprise insider preview builds running on ARM VMs in Azure. ARM-based VMs are integrated into your Azure experience and accessible through the Azure portal, the Azure Resource Manger, the Azure CLI, and SDKs. ARM-based VMs support VM scale sets to help you deploy highly available, centrally managed, and scalable services with support for VM resizing. And the Azure Marketplace supports ARM-based images and extensions with support for the ARM VMs in the Azure Monitor and Preview. ARM-based VMs will support a range of operating systems with Ubuntu 20.04, 18.04, and CentOS 7.9 available in preview. Red Hat, Debian, SUSE, Flatcar, and more distributions are coming soon. You can choose to deploy ARM-based VMs in Azure regions across West US 2, West Europe, and West Central US during the preview, with support for more regions coming soon. Azure ARM-based VMs are priced 20% less than comparable x86-based instances, with ARM-based spot virtual machines available in preview and reserved instances available at GA. You can view more details on the Azure pricing page or through the link on this slide. We're excited to have you on board our ARM-based VMs preview. Please go to aka.ms/ARM64VMs preview and fill out a short form to apply for access. Thank you for listening and asking questions, and please welcome my colleague Priya as she introduces our new EBS Series VMs.
Thank you, Mo. And hey, everyone, I'm Priya Shanmuga Vadivelu, and I'm a Senior Program Manager in Azure Compute at Microsoft. I'm very excited to meet you all today in this webinar. So in addition to the new ARM-based VMs, we are thrilled to announce the general availability of the EBS V5 series and EBS V5 series based on the latest Intel Ice Lake processor. So these are our new and improved memory optimized virtual machines that offer up to a 3 times increase in VM to disk throughput performance and IOPS than the previous generations. Now, these VMs offer 120,000 in IOPS and 4,000 megabytes per second of remote storage throughput. Our customers who run data-intense workloads, such as SQL Server, Oracle DB workloads, or be it any type of relational or non-relational database applications or data analytical applications, have let us know about their increasing needs for remote storage performance. And so here we are with the new and improved memory optimized VM series with an increased IO to core ratio offering 120,000 in IOPS and 4,000 megabytes per second throughput to meet your needs. This VM series comes in 2 flavors. The one with local disk is EBS V5 series, and the one without local disk is EBS V5 series that you can choose from based on your workload requirements. Now let's dive deeper into the performance improvements we have made in every generation. The graph on the left shows the throughput improvements, and the right one shows IOPS improvements. The highest remote storage throughput that is offered in EV4 is 1,200 megabytes per second. We have increased the throughput to 2,600 megabytes per second on EV5, which is about 2 times more. Now with the EBS V5 series, we offer even higher max remote storage throughput of 4,000 megabytes per second, which is almost 3 times more than what is offered in the EV4 series and will benefit your data-intense workloads. We've also increased the max IOP limit on the VM side to 120K on EBS V5 and when used with premium SSDs. With UltraDisk and the EBS V5 series, you can get a maximum of 160,000 IOPS. Now let's check out some of the benefits that you would have with the EBS V5 series. With the higher IO to core ratio, you can now consolidate your existing workloads into fewer and smaller VM sizes and get the desired cost savings. For instance, let's take the 32 vCPU VM size. The maximum throughput that is offered in the EV5 series is 865 megabytes per second. However, if your workload needs much higher throughput for the same VM size, you can now choose the EBS V5 series, which offers 2,500 megabytes per second throughput. And this is almost twice the throughput and allows you to get the desired cost savings. Also, the EBS V5 series have about 2x more in IOPS than the EV5, which will benefit your most demanding and business-critical transaction-based workloads. You'll also be able to hit a maximum of 160,000 in IOPS and 4,000 megabytes per second throughput with UltraDisk and will benefit your data-intense applications that need higher remote storage performance. And finally, if you are on one of the older generation constrained core VMs, try the new EBS V5 series on the EBS V5 and get the benefit from cost savings. The EBS V5 series is available in sizes from 2 to 64 vCPUs and up to 512 gigabytes of RAM. The core to memory ratio is 1:8. Now, we know that certain applications, such as batch jobs, generally require a baseline performance most of the time, but higher performance for a short period. And bursting can be very helpful in these scenarios. Azure offers the ability to boost the storage IOPS and throughput performance through bursting on both virtual machines and the disk. The EBS V5 and EBDS V5 series are enabled with bursting support, allowing you to hit about twice more in IOPS and doubled or even higher on throughput, depending on the VM size. For instance, let's take the 8 vCPU VM size. The baseline performance that is offered at the VM level is 22,000 in IOPS and 625 megabytes per second throughput when used with Premium Disk. With bursting, you would be able to achieve 40,000 in IOPS and 1,200 megabytes per second throughput, which is almost twice the performance. We also offer similar burst performance with UltraDisk on the EBS V5 series. So we have highlighted the improved price performance that you would see with the EBS V5 series, but we further want to drill down and show some numbers here. Now let's consider a scenario where your data-intense workload would require a throughput of 1,200 megabytes per second. Earlier with the EV4 series, E64 SV4 is the available VM size to meet this performance and would roughly cost $2,943.36. With the latest EV5 series, you could get the desired throughput at even smaller size, 48 vCPU, which saves 25% in your compute cost compared to the EV4 series. But with the new EBS V5, the desired throughput can be achieved at 16 vCPU VM size, which is 4 times lesser in core count and saves 70% in compute cost compared to the EV4 series. That's a significant saving that you would get. GigaOM did an extensive performance study between Azure's EBDS V5 and AWS R5P EC2 instances with the TPC-E and TPC-H derived workload types. For context, the TPC-E derived workloads are OLTP-based applications, and performance is measured in transactions per second. The TPC-H derived workloads are OLAP applications that measure the query performance in a data warehousing context. The test configurations for the TPC-E and TPC-H are similar. They use the Microsoft SQL Server 2019 Enterprise Edition on Windows with Azure Studio E32 BDS V5 VMs and premium SSDs. On the AWS side, the instance was configured with Amazon EC2 R5P 8x large instance and GP3 volumes. GigaOM selected the R5P instance with compatible specifications for IOPS and throughput and the same cores as it was set up in Azure. They emulated configurations on premium SSD and GP3 volumes for storage, maxing out on IOPS and throughput specs for a direct comparison between these instances. And based on their test for the OLTP workload, the EBDS V5 series showed 42% higher performance, that is 1,657 transactions over 1,170 transactions with AWS R5P. And in terms of price performance, Azure is 23% better than AWS with pay-as-you-go pricing. Further, when combined with the 3-year reserved instance and Azure hybrid benefits, you get 31% better price performance in Azure. In the second type of test based on OLAP workload, the EBS V5 series shows 41% better performance, which is 317 queries per hour in Azure versus the 225 queries per hour with AWS R5P. Again, with respect to price performance, Azure is 21% better than AWS with pay-as-you-go pricing and 25% better when combined with the 3-year reserved instance and Azure hybrid benefits. As you can see, the EBDS V5 series has better price performance than AWS R5B, and Azure continues to be the best cloud to run your SQL Server workloads on Windows. More details on the performance study are available in the resources section. Finally, we are pleased to share the great responses we received from our preview customers. Saas runs a portfolio of analytical and AI-based applications on Azure. Their workload requires very high I/O throughput to process large volumes of data. And on EBS V5, Saas runs several computational and I/O intense tests to measure concurrent and mixed analytical workload performance. They found the EBS V5 series offers an excellent overall performance, meeting Saas application requirements. Our other customer, Blue Yonder, runs their supply chain optimization platform, and they need higher I/O throughput across different workload sizes. With the EBS V5 series, they could run solutions up to 20% faster and larger workloads than before, while also reducing the overall total cost of ownership. Silk is a virtual SAN solution for applications that demand high I/O throughput at low latency. The Silk platform aggregates the egress performance from multiple VMs to enable maximum ingress performance to a single database VM. With the EBS V5 series, Silk measured 10 gigabytes per second sustained throughput to a single SQL Server DB. Our customers are excited to onboard the new EBS V5 series for their data-intense workloads and unlock the price performance benefits. And we will continue to focus on increasing the overall system performance of the Azure IaaS offerings and always offer the best price performance. I'd like to hand over to my colleague Sasha to share about other Azure innovations now. Over to you, Sasha.
Thank you, Priya. Hello, my name is Sasha Melamed, and I'm a Senior Product Manager in Azure Compute Virtual Machine Sizes team. Today, I'm excited to pre-announce our new storage-optimized L-Series virtual machines. Some customers can be familiar with our existing LSV2 virtual machines, which provide superb local disk performance together with the highest in Azure SSD capacity. Many customers leverage these virtual machines to run their big data and data analytics applications, as well as all sorts of databases, including SQL and NoSQL. With the new V3 L series, will deliver the most asked improvements. While maintaining excellent local NVMe capacity, IOPS, and throughput, the new storage-optimized VMs will get the newest processors. There will be two flavors. LASV3 series will run on the latest AMD third-generation EPYC processors, also known as Milan, and LSV3 series will running on the latest Intel Ice Lake processors, which are the third-generation Xeon. Both processors can work at up to 3.5 gigahertz frequency. We know that different applications can be optimized differently for various processor architectures and instruction sets. So our customers will be able to select the virtual machine series that will be the most price performance efficient for their use cases. Additionally, networking and remote storage throughput and IOPS have been increased by at least 25%. LSV3 and LASV3 series will also support our new flexible orchestration mode for virtual machine scale sets, which allows to deploy highly available large-scale cloud infrastructure quickly, reliably, and easily. On this slide, you can see that the key specifications for the LSV3 and LASV3 series are remaining the same as they were for LSV2. We will have the sizes ranging from 8 to 80 vCPUs with up to 640 gigabytes of memory and 19 terabytes of fast NVMe drives. Details on all the characteristics and improvements of these new VMs will be published on the launch date. Our internal tests and feedback from early preview customers demonstrated that the new virtual machine series resulted in up to 200% performance improvements compared to the existing LSV2. Certainly, this depends on the particular application and architecture, so we will encourage all our customers to conduct tests of their workloads on both series to select the most optimal one. We are going to release the new L-series virtual machines by the second quarter this calendar year to the most popular regions and ramp up later this year to have them available wherever we'll have customer demand. With any questions and inquiries regarding the storage optimized virtual machines, please reach out to our team at L_series_preview@microsoft.com.
Thank you so much for joining us today. This does conclude the audio portion of our webinar. However, we will be live for a little while longer to answer your questions. If you haven't already, please submit your questions into the Q&A window. Please note that the questions and answers are available every time you access your webinar console with the on-demand link. Thank you so much for joining us today, and we hope to see you in an upcoming webinar soon. Have a great day.